Hello everyone, it's glad for me having this chance to introduce our liquid helium-free MRI to you. Hope you have a nice day. And please check the screen that we have this advanced next generation 1.5 liquid helium-free MRI now. And it's very smart appearance, and it's a very convenient operation, and it's a modern design for the radiologist, and all the design are most modern and most fit for the hospitals in our area. My introducing will including some parts. The first part of my introducing is the advantages of the helium-free, and in this part we are going to introduce what is the helium-free and what is the with helium 1.0 MRI, their difference, and what is the advantages of the liquid helium-free. And before this presentation, we already set videos, and in the videos that we already know that the MRI is consist of some main parts. The main parts, as in the screen, that we can see the main part including the magnet, the gradient coil, the RF coil, and the receiver coil. And all these parts are located in the shading room, and they connect with the spectrometer and the workstation. And the doctors, the radiologists, they stand in the operating room and operate the workstation to scan the patient. And in the meantime, the accessories including the compressor, the water chiller, the heat switch, and they are the accessories of the MRI system. So in this review, in this schematic, we can see that the MRI structure, as in the videos we just played, is easy to understand. Now I'm going to introduce the main components, the magnet. This page shows that the 1.5 magnet history, and from the left to right we can see that prior to the year 2000 they are in the market, they are only regular magnet with helium, and they are small boil-off type, which means this type of helium will the helium will boil off day by day, and that is a big cost. And then after year 2000, from the year 2000 to the year 2020, the regular magnet with helium but with zero boil-off technology comes to the market. This type of liquid helium, this type of magnet, the liquid helium, will not boil off. Using this magnet around 5 years, and we just refill the liquid helium one time, and we just need to maintain the cold head. But this type of magnet still have a problem, is that this type of magnet is easy to get a quench. A quench is something like the explode of the magnet. All the liquid helium will lose in the quench, and in the next some page we will see what happens during the quench. So this is a big problem. If quench, the hospital will lose a lot of money. So now let's see the right part, the latest technology of the magnet, liquid helium-free MRI since the year 2020. And the latest technology of the liquid helium-free MRI is a revolutionary design. Totally get rid of the liquid helium and boil-off headache, and also avoid the quench risk for the hospital. So they are very interested for the hospitals. Okay, in this page, we can make a brief comparison of both magnets. The left one is the liquid helium-free superconducting magnet, and the right one is the regular superconducting magnet. The difference between the two types of magnet is actually, let's pay attention to the cold head, the left up part, and the main difference between the two types of magnet is what is the conductor between the cold head and the coils in the magnet. The traditional type, the liquid helium type, the cold head connect to the coil by the liquid helium. But the latest part, the left one, that we can see the cold head connect to the coil by the solid state cryogenic medium, which is a very new technology that can improve the heat dissipation and also the connection of the heat, so that we can make sure there is no liquid helium and the coil is still working okay. So the liquid helium magnet coils are in direct connection with the coils, and the cryocooler will work together with the solid cryogenic medium cool the superconducting magnet coil directly. This is the most advantage point of the liquid helium-free MRI. And after reading the principles of the two types of magnet, and we can see what is the difference, what is the advantages of both types of magnet. So let's see, the overall maintenance cost is much less. Now, with the liquid helium-free MRI, in the gantry, there is no liquid helium, zero liquid helium. So the liquid helium loss, nothing, even the quench happens. So the magnet can be recovered automatically within 3 days after quench, and no engineer required for the on-site visit. So this is the most important part of the liquid helium-free MRI. The second point of the advantages of the magnet is the magnet is more intelligent and better user experienced. In the magnet of the liquid helium-free MRI, we can very easily ramp down if any electricity outage and ramp up again automatically once the electricity recovers. We just use the one-touch mode to enable all these works just in one touch. And the third point of the advantages of the liquid helium-free MRI is the transport, and the installation is much easier. It can be installed anywhere in the world, completely get rid of the helium. Because the helium is sometimes restriction and sometimes very expensive in some countries. But now we don't need helium at all. And in the room, in the shading room, there are no quench pipe needed, so that the service height, the height of the room, enables the site selection easier and more flexibility. And we can transport the magnet much easier using the regular container and the most cost efficiency. And the highly recommended as the best MI choice for the countries who are lack of liquid helium supply. The last point, the last advantages of the liquid helium-free MI is it's more safer, more eco-friendly, and better looking. And it protects the liquid helium source. And also, no cryogenic liquid, no risk in cold injury and asphyxia for the patient. And the entire magnet looks better and much more elegant. So let's check this page, the comparison between the traditional helium-free MRI. We can see that the gantry consists of much liquid helium inside. So if the quench happens, what will happen during the quench? We can see that, oh, it's get liquid helium leak to outside of the room by the quench pipe. So the quench means the magnet explode and outside of the magnet room, which is dangerous to the patient. And also the hospital, the management of the hospital will lose a lot of money during a quench, more than 50,000 USD and quench. And the quench may happen not one time, it may happen repeat. So that is a great potential risk for the patient. So our liquid helium-free MRI solve this problem. Let's make a comparison between the liquid helium-free superconducting magnet with the regular superconducting magnet. The right column is the regular SC superconducting magnet. The left column is the helium-free superconducting magnet. If we compare the cooling method, that we can see the regular magnet still need helium, but our liquid helium-free MRI does not need any helium. And because we don't need the quench pipe, so the RF room minimum height is reduced to the 2.5 meters only, while the regular magnet need around 3 meters. So it's more room saving. It means the liquid helium-free MRI can be installed in some very small rooms. For the hospital, it's a very good news because some hospital, they only have small rooms and less ceiling height. And the market access, this type of MRI, we can go to the global market while the regular superconducting magnet is not possible for countries where the liquid helium supply is difficult and high cost. If we compare the maintenance cost, the zero helium consumption, both types of the magnet is zero helium consumption, but the regular superconducting magnet may happen the quench, as we just saw in the videos, but the liquid helium-free MRI will lose nothing during the quench. And the intelligence, the liquid helium-free MRI has an auto-ramping control and one-touch mode that help the doctor, the hospital to get the magnet in time and on time. The international shipping of the liquid helium-free MRI is also easy. It just uses the regular cargo with a less cost, while the regular superconducting MRI magnet is a dangerous type cargo with a very high cost. And the user experience between the both magnet is also, we can see the liquid helium-free because it can ramp up and ramp down very easy and anytime. But for the regular superconducting magnet, if the hospital want to ramp down the magnet, for example, if the wheelchair is attracted to the magnet, it means the dangers to the patient. If the hospital need to ramp down the magnet, they will also lose the money. So liquid helium-free MRI is more eco-friendly and more convenient. And let's check the revolutionary platform of the liquid helium-free MRI. They comes to the market since the year 2020, while the traditional type comes to the market before 2000 is an old technology. So the new technology have a modular design and highly integrated magnet, while the old type traditional MRI only has a less integration. The design conception is also user-friendly, and the user experience is we also providing the best human-machine interface, while the old type of magnet has nothing. In this comparison table that we can see our liquid helium-free MRI has 0 liters. It's a 20 liquid helium. While in the market, there are other liquid helium-free MRI. The brands is something like Philips and like Canon. They still have a few liquid helium in the gantry. Like the Philips, they produce a 7-liter magnet. And the vessel pressure comparison, because we are full 100 liquid helium free, so there is no pressure risk even after the quench. But the other liquid helium free like Philips, they still have high pressure inside the vessel. If the quench happens, it's still dangerous for the patient. And the vessel pressure, and if we compare the cooling method, we use the innovative 2.0 technology, while the Philips still using the conventional conductive heat transfer. They are still using a little liquid helium to connect. So, and the recovery time upon the quench, our liquid helium-free MRI just need less than 2.5 days, while Philips still need 3 days to reset the magnet. And if we compare our system to other regular with liquid helium type magnet, superconducting magnet, that in this table we can see all the parameters we are same or better than the old type, including the magnet strength, including the stability, including the homogeneity, including the 5 gauge line, including the inner bore, and including the dimensions. And in the dimensions, we can see because we don't have the maintenance tower and we don't have the quench pipe, so our heat requirement is minimized to 150 millimeter. So that is very nice for the hospital who has less room size. And the image quality comparison, we test that both type of magnet has the same image quality. And here in this table, we want to compare the liquid helium-free MRI with the traditional helium MRI, and also compare with the permanent MRI, which is very popular in the market. So let's see what is the advantages and what is the disadvantages of the different MRI systems. First line, let's check the image quality. And we can see that both helium-free and helium MRI, because they are 1.5, so their image quality is good, while the permanent MRI less than 0.5. Sometimes they are 0.35 or 0.3 Tesla. They are bad image quality. The scan speed 1.5 is faster than the permanent MRI. The max patient per day, the 1.5 MRI is more than 50 patients per day, while the permanent MRI can scan only less than 15 patients per day. They are slow, and the electricity power cost for the liquid helium-free MRI and the traditional helium MRI is nearly the same. It's approximately $1,500 per month. In this line comparison, the permanent MRI is better because the electricity cost, they are just $500 per month. But in the meantime, they lose the image quality and the scan speed. And the system stability is the weakness point of the middle cooling. The 1.5 helium MRI is their weakness because the stability is low. They are easy to get quench, as we just saw in the videos. But in this point comparison, the liquid helium-free MRI and the 0.5 permanent MRI, they are very stable. They don't worry about quench. And in my second part of the reporting, I'm going to report the introduce the system features of the liquid helium-free MRI. Let's see what is the system feature. Some doctors may pay attention to the gantries of the magnet, the bore, the inner bore. The inner bore is 600 millimeter, which is an international standard, which means more than 90% of the patient is very easy to get in this bore. And when the RF amplifier comes, it's also a very important core component of the MRI, as we saw in the schematic before. So regarding this part, our system used 18 kilowatt of RF amplifier, which assure a strong proton excitation power and with produce homogeneity, better homogeneity of B1 field. And we also use a full digital 18-channel spectrometer with optical fiber transfer, which is a very late technology, produced higher signal-noise ratio for the image quality. So these two important components of the MRI is like this. And let's check another very important core components, this gradient system, as we saw in the video. The gradient intensity of this system is very high. It reaches 38.5 millitesla per meter when the slew rate comes to as high as 175 millitesla per meter per millisecond. So such a strong gradient asks for water cooling. So this system also configure water cooling system. And another very important part of the system is the coil, the receiver coil. This coil will decide what clinical applications we can scan. So in this table, we can see the system provide a head and neck joint coil together with 16 channels. And if we go to the spine, the thorax spine, lumbar spine, we use the 16-channel spine coil. And with the abdomen and some other parts, we use the universal flexible coil. And for the abdomen only, we use a flexible body coil to improve the abdomen body imaging. And we can also use the shoulder coil, 8-channel shoulder coil, to get a very good shoulder dedicated imaging. And we use the wrist coil to get a very good wrist joint and also palm imaging. And with the mammogram coil, in this coil we use this 8-channel breast coil to get a female breast imaging. And for the ankle scan, we use the 8-channel ankle coil to scan the ankle. For the knee, we have a dedicated knee coil, 8 channels to scan the knee, and also the TM joint, temporal mandible TM joint. We produce a 2-channel TM joint dedicated coil for get a high resolution TM joint coil. And with the full body imaging, we produce the one-time position, full field imaging solution with the head, neck, spine coil works together, and that we can get the full spine or full neural system imaging like this clinical. It's also a very nice application for the hospital to get our income. And regarding the very convenient, very ergonomic design for the radiographers to position the patient, we can see that our motor-driven patient table has a max load 200 kg for patient, and also the position accuracy is less than 1 millimeter. The operate at both sides of the magnet, and so it's very easy to operate both left or right as convenient. And our patient table is 4-direction movement table. It can go up and down and in and out. The operation is very easy and convenient. So if we make a summary, if we make a conclusion of the product features, we can see that the main advantages of this system has at least 4 advantages. Let's conclude like, first, it has a less site requirement. Second, It has advantage 16-channel RF system, both the spectrometer and the scan coil. And the liquid helium-free 1.5 magnet has so many advantages compared with the regular superconducting 1.5 magnet. We just make a comparison between our system and the systems come from the other counterpart like Philips. And we also have a very strong hardware like the advanced gradient system to improve the image quality. So the next part, let's check the image qualities, clinical images of this system. Let's make a comparison between our clinical images compared with a famous brand in the market, such as Philips and GE. So we think our system, our routine image quality is 100% meet the radiologist demand. So that means if the hospital choose our system, they can 100% satisfied with our routine image quality. So what is our leakage? What is our weakness point compared with the very famous brand like Philips? Is actually in a few advanced applications, such as the spectroscopy, clinical application, like the board application, which is not commonly used in the hospitals. It means if the hospital choose our system, in our country, it's very easy to satisfy the radiologist, because we are 100% meet their demand. So they just lose a few advanced, which is not commonly used clinical applications with a very, very good price comparison with Philips. So that is our advantage. In the next pages, I'm going to show you our image quality compared with the very famous brand, our counterpart in the market. That you can see our image quality is 100% satisfied. With the head routine image, we can see a good gray matter, white matter contrast, and organization structure is very easy to define, and with a very uniform flare sequence signal, high signal, and right genome of colosomes. And in this, even this very small structure, our system can very easily distinguish and diagnose. That's our advantage. And in this page, we can see the brain routine images, including like the T1, T2 fast recovery, and the T2 third, and also high definition diffusion, ADC mapping, ASWI, and 3D TOF MRI, and the MRV for the venous in our brain, and also the inner auditory canal imaging, the T1 weighted pituitary imaging, and the T2 inner ear, very thin slice, as thin as 2 mm slice. They are very easy to get a good image quality. Let's check our high definition 3D TOF artery imaging with the optimized K-space refueling, that we can see the arteries, both the anterior arteries and the middle arteries, and they are very clear seen, and the connections, the continuously, the image, the artery is very clear. And in this page, please check our high definition SWI imaging based on the magnetic susceptibility difference between different tissues imaging. And this sequence is very easy to distinguish our small vasculars in the brain. And in this high definition, high contrast imaging, that we can very easy diagnose the vein malformation or iron deposition or very small lesions. And if we zoom in and zoom out our image to check the thalamus basal ganglia image, which is very important for the neurosurgical. So we can see that this MRI shows a very clear anatomy structure in this area. And our high resolution cervical and carotid plaque imaging is very easy for the patient to, as we can see, the right carotid artery, the plaque is shown very clear here. Please also check our routine T-spine and L-spine, and this lumbar spine and the thorax spine, the vertebral body, the intervertebral disc, and also the spinal canals. All the structures in this image are very shown very clearly and without the artifact. Also, we can see the different parts of the full spine imaging from the cervical spine, from the lumbar spine, from the coccyx, and also from the axial imaging of the cervical spine and axial imaging of the lumbar spine. They are very clear. In this abdomen imaging, we can see the reduced magnet-sensitive artifacts and apparent respiratory motion artifact. So the different tissues like the liver, like the kidneys, like the pancreas, and some parts from the bowels, they are shown clearly without the artifact. And in this image, we can see another part of the abdomen imaging with a different contrast, like T1, T2, diffusion weighted imaging, and in-phase and out-phase and dephase with a phase 1, phase 2, phase 3 MRCP for the gallbladder, and also MRU for the uterus, for the urinary, and also the true-phase system for the water, the blood, and also they are shown bright in this image. The abdomen MRCP imaging, let's zoom out and we can see a very good image here. Both the bladder and also the bile duct in the liver, they are shown very clearly. And for the uterus, and we can see the membrane, the different membranes, the different section of the uterus, and also we can see the femur bone. They are all shown in the image are very clear. For the female, we can use this MRI for the mammal gland examination. As we can see, the mammal gland is very clear, and all the gland canal can be seen very easily. And let's see the muscle skeleton imaging. So in this imaging, we can see different contrast like T1 and T2 fat set, and we can see the different structure of the shoulder, the knee, the femur bone, and also the T1 and T2 imaging from the wrist, from the ankle. If we zoom out and zoom in, and we can see that the very clear small structures like the meniscus, the cartilage of the knee joint, and here in the right image we can even the popliteal artery is very clear seen in this fat set MRI, has a very high signal noise ratio. And for the routine palm imaging, that we can see the tendons, the muscles, the bones are very clearly shown with the tendon anatomy structure, which the surgeons, they like to see this kind of image. So after the reporting of the clinical images, the part 4, I'm going to introduce about our installation, training, and the maintenance part. And to install this MRI, that we can see this MRI is, we recommend approx 6.5 meters length and 5 meters width for scanning room. And in the meantime, we place a 3 meter width equipment room in the left one that we can place all the accessories like the monitor, the spectrometer, the gradient amplifier, the power, the helium machine. The helium machine means the cold head only. This system is helium free, and the regenerator and also the air conditioner and the workspace, they are designed in 3 meters with room and the operator room where the radiograph operates this system. We have put a die-printer operator table, and we also can set a waiting room for the patient. So this typical room design is for reference. And regarding the training plan that we can train the engineer from your side or from the hospital side or from any third-party engineer, we produce the engineer training. The duration of the engineer training is 1 week typically. During the engineer training, we will teach the device function, and we will also teach all the use tips and all the operation tips following the operation manual. And we will also teach the daily check and the maintenance introduction. And we will also teach in this 1 week training is how to replace the spare parts. Like in the training can be works in our country, or can be done in the factory, or can be done in the hospital, depending on the customer requirement. And we also produce the training for the medical staff, like the radiographers in the hospital. The typically training is also 1 week. During the training, we will produce the equipment function introduction, operation manual introduction, and also device maintenance, routine maintenance, and how to efficiently use we of the device for the medical staff. Typically, time is 1 week. So above is my introduction about our system. I hope you have a nice day. Thank you very much.